You guys missed the very beginning. I'm going to flip back to that slide for the recording. Okay. The cohort effect, this is important for the fact that cohort effect means that same groups share certain characteristics. We talked about that the first day of class. So everybody in your age group is going to share some characteristics with you, right? We'll see that more in a minute. Finally, we have a cross-sequential design, which is kind of a combination of the two. You start with different age groups, so different people in groups by age, and then you follow them for a shorter period of time, but over time. So you're getting a little bit element of longitudinal and cross-sectional there. This allows you to cover more age groups, right? Without having the study go on forever and ever. And there are some, disadvantages to that. So let's look at a little more detail. Cross-sectional, several different age groups studied at one point in time. Measurements of different people, okay? For example, say you want to study children from 6 to 12. You just have one group of 6-year-olds, another group of 8-year-olds, a third group of 10-year-olds, and finally a group of 12-year-olds. So we can study differences between these ages, but what it doesn't control for are the individual differences within these groups, so the within group variance here. In a longitudinal design, one participant or group of participants is studied over a long period of time, repeated measurements of the same people, okay? Again, this is the best thing for developmental designs because it allows you to evaluate changes over time, controlling for things such as the cohort effect. Okay, so here's a specific definition: impact on development when a group of people share a common time period. So they have similar experience, right? So for example, 1 year you start with a group of 6-year-olds. You measure them again 2 years later. 2 years after that, you measure them when they're 10, and 2 years after that, you measure them when they're 12. So you're still looking at, mean whatever you're measuring at 6, 8, 10, and 12 years old, but you're actually having the same individuals, and thus you're not going to capture any of that variability between cohorts, right? Finally, we have a cross-sequential design. And here you start with cross-sectional, okay? So you have different groups of different people, okay? And then you follow them for up to 6 years. So for example, you might have year 1, you test a group of 6-year-olds, a group of 8-year-olds, a group of 10-year-olds. 2 years later, you test them at 8, 10, and 12. And 2 years later, you test them at 10, 12, and 14. And you're actually getting a broader age range here because you get 14-year-olds, you have, in some extent, you're measuring the same people over time, but you're also measuring different. So if we know that longitudinal designs are the absolute best, why do we sometimes not use them? Well, because they're costly, they take a long time, and you have a lot of participant attrition. This means you lose participants. Okay, for example, children move away. When you're following kids from young to older, they move, they switch schools, and maybe you're send your research in a school. Their parents get divorced, and whatever parent they end up with is into the research thing. And then, as I told you before, for minors, parents give consent to research, right? But the child has to give consent. So what a 2-year-old or a 3-year-old or 6-year-old or a 8-year-old is happy to participate, you get to a time where maybe they don't want to. Okay, so for little babies, they just assume that they're happy they're getting consent. But once children can read, they might actually show them a form and have them sign it, and maybe they're going to decide they'd rather stop participating when they're older, right? So for various reasons, you lose participants over time. So here you have an example all spelled out. Okay, so it's how you have cross-sectional design, longitudinal, and cross-sequential, how it would work for different age groups, right? But you're still seeing everything from 6 to 16, but how you do it is different. Any questions here? Longitudinal designs are always good because it controls for within group variability, the differences within the individual. But they're particularly important in developmental, however, they're harder and more costly to do. Okay, here's the slide from your textbook, which you can reference later. It's just the same thing I just told you with a slightly different example. Okay. Again, you can always download the PowerPoints and see these things later. Okay, so moving on. One of the biggest issues in developmental psychology is what almost everything is nature versus nurture. So to what extent are our characteristics, psychological and physical characteristics, determined by our genetics, what we're born with, right, our DNA, and to what extent are they determined by our environment, nurture? Okay? That's the big question for a lot of developmental psychologists. So nature is a theory that physical and cognitive development is genetically determined, really puts an emphasis on that influence of those characteristics, our DNA, right, on everything we're interested in, personality, physical growth, social interactions, and so forth. Compared with nurture, the theory that physical and cognitive development is primarily determined by environmental factors, okay? Of course, in the end, it's going to be both, right? Behavioral genetics focuses on nature versus nurture and often looks at what they call a gene-environment interaction. So your genes are what carry your genetic code, right? Obviously, that's important. You're born with your genetic makeup. You can't escape that. But how your genes are expressed very much depends upon the environment. Okay, the phenotype. We know from a lot of gene environment interaction studies that people who are born with certain alleles, so different alleles, are more or less predisposed to be affected by the environment. So you have sensitive children who are very sensitive, and if they are brought up in a harsh or non-nurturing environment, they're going to have very poor outcomes. But if those same sensitive children are given a nurturing environment, well, they're going to turn out to be super creative artists or whatever, right? Whereas you have children who are more resilient and are unlikely to be as affected by poor environments, such as less access to educational opportunities that lead to families, etc. They're not going to be as affected. They're going to be more resilient to be able to get through that. On the other hand, they're also that lack of sensitivity, right, is also going to make them less likely to become hard. Okay, here's a little video we're going to watch to show how scientists really study the nature versus nurture argument. Not yet down. It happened the other day too. I don't remember how I solved it. Let's see. Well, we're going to maybe. Up. I solved it how I did last time. So we might not be seeing this. Let me see. I'm not hearing anything. Oh, dear. Hey, you guys online, you can hear me talk, right?
Yes.
So we just can't hear this. So this is not the flaw with this. Nope, that's not doing it. Doing it. You might have to give up. No other audio. Okay, fine. All right. So she's basically, I'll give you a summary of that. She's basically talking about studies of twins who are raised apart. So they are adopted at birth and they live in completely different places. And one of the Jim twins, I think your textbook might mention them, but all of this is just that these people who are raised apart, they grew up with weird, identical idiosyncrasies, like the way they hold a beer can, right? These Jim twins married, the first wife had the same name, the second wife had the same name. Then one got divorced and has remarried someone else. The one is still married to them, but you know, she's probably really worried, which is what she mentions there. And you see later a pair of female twins, they meet for the first time wearing like each has 7 rings and 1 wristwatch. And so all these really weird like personality quirks that they share, even though they're raised in completely different environments, sometimes in different countries and different religions, and yet they still share. These are identical twins. Identical twins have exactly the same genetic makeup, okay? They're called monozygotic. We'll see that in our slideshow in a minute. Fraternal twins have different, and we talked about that on Monday as well. So let me stop this since it's totally not working for me anyway, and go back to the slideshow. That's too bad. I'm gonna have to contact these people. So, genetics and development. Here we have the strand of DNA there at the right. So genetics refers to the science of inherited traits. That strand of DNA, okay, that's a molecule that contains our genetic makeup. So all of our genetic makeup. It's formed in a double helix. The rungs are ends, okay? They contain our genetic code. A gene is a specific section of DNA having the same arrangement of chemical elements. So a gene is made up of certain, it's not chemistry, just like anything else, chemical elements. It's just a section of your DNA. There's a lot of different genes. We're going to talk about a fairly simplistic picture of it. You have dominant genes and recessive genes. Dominant genes control the expression of a trait. Recessive genes only influence its expression when it's paired with another one. So we get pairs of genes, right? And we get one from one mother and one from our father. Okay, so we get pairs of genes. In that pair, if something is dominant, it controls how things are expressed. So for example, eye color. Now it's more complicated than this, but this is always a good example. Brown eyes, brown eye color is dominant. Blue is recessive. To get blue eyes, you have to inherit a blue recessive gene from each of your parents. If you inherit one brown and one blue, your eyes are going to be brown. Because it controls and makes your eye, the color expressed be brown. A chromosome is a strand of genetic material as DNA. It's just a whole bunch of it. So let's look a bit more. Chromosomes, large segments of DNA. They contain our genetic blueprint, okay? There's a lot of chromosome disorders. Let's look at the right before I get into that. So on the right, we see the nucleus, okay? The nucleus of every cell in your body contains chromosomes, okay? And everything is gonna contain all of your 46 chromosomes, okay? And all the blueprint, all your genetic blueprint, okay? Every chromosome has genes. which are the simplest unit of heredity, okay? And genes are made up of DNA. So remember, genes are segments of DNA, right? Chromosomes are just large, whole bunch of it, okay? Chromosome disorders. Down syndrome is probably the one you guys have heard of most commonly. Down syndrome is a chromosome disorder. Klinefelter's, Turner's, okay? And then you have genetic disorders like PKU, cystic fibrosis, and so forth. So chromosomes are just errors in the structure of your chromosomes, so how many chromosomes you have, okay? Whereas genetic ones are just part of your genes. So let's look, well, I mean, I guess. For example, we're gonna have an example of PKU, that phenylketonuria, not sure that's how you pronounce that. It's a genetic disorder that means that you cannot break down phenylalanine, which is a component of food. So if you do not have that enzyme, they have to identify it right away. The newborns are tested for PKU. Okay, that way they can actually help them to survive. So PKU is respect. To actually have PKU, to be able to break down that, you have to have two PKU genes. So if you see this example, we have the mother, that's the one that gives you the disease. You have one, the father has two, just two big genes, who does not carry the PKU. None of the children are actually going to have PKU because the big T is dominant. So on average, these people, you have one recessive and one unrecessive, is that two children who are completely normal and with two dominant big T genes, and two that are carriers. They will not have PKU, but they can give it to their children. So how would it look like if you have two carriers? Two carriers both have a dominant, so you can't have tell. There's no way to tell someone carries it. They appear normal, but they carry a recessive. And if you have two carriers, then on average, one of the children, so 25%, is going to actually exhibit PKU and happiness. Two will be carriers and one will be normal. So this is just a different way that, because every child is going to inherit one, right? So I make this question. The same holds for sickle cell anemia. Okay. To have sickle cell anemia, you have to have two possessions. So the only way you can is if you have a mother and father who both carry. Normal gene will always be dominant, and they will not exhibit sickle cell. The sickle cell has lost that. Apparently, people who have sickle cell is less likely to get malaria. So it's not like it's a terrible thing. I mean, but it is certainly bad. Okay. And like I said, eye color, there's a lot of things that depend that, you know, eye color, colors of fur. I think I have actually more examples here. Let me see. Okay. Conception to birth, genetic material in cell nucleus, 23 pairs of chromosomes. We have 46 chromosomes altogether, but 23 pairs. Okay? You get 23 from your father, 23 from your mother. Okay? The chromosomes have their genes, and that's how, of course, you can mix up the PKU or whatever, because you're getting one from each parent. Polygenetic inheritance just refers to the fact that your traits are controlled by many different genes. So what does this mean? Well, effective power is father. Now, let's cover that first. Everybody carries two sex chromosomes. Okay, males carry X and Y. You guys probably already know this, but I have to repeat just in case someone doesn't. And male is carrying X and a Y, female is 2 X's. So whether or not the child is male is only determined by the father. Okay? You will always inherit an X chromosome from your mother. Always. Everybody's got at least one of those. From your father, you can inherit either an X, in which case you're female, or a Y, in which case you're male. Right? Genes that are located on a sex chromosome, X and Y, is a sex-linked field. So we talked about that when we talked about color blindness, remember? Males are more likely to be colorblind. Baldness, and definitely more likely to be bald at a young age. Everybody gets thinner hair as they get really old. Males, unfortunately, can get thinner hair sooner. Hemophilia, orange coloring cats. I don't know if you guys ever noticed that orange cats are much more likely to be male. They can be female, but they're much more likely to be male. Okay? Tortoiseshell cats too. So we're going to have a little pause here and have our discussion for the day. The discussion topic today is physical punishment. Were you spanked as a child? If so, what effect did it have? Did it help? Did it make it worse? Might negative punishment, such as timeouts, be more effective than positive punishment, such as spanking. So negative is you take something, get away. The timeout takes away your freedom. Right? Positive means you add something. Spanking, you're adding something unpleasant. And finally, talk about whether or not we should outlaw physical punishment. Why or why not? So let's have the inside people have a group of 4 and a group of 3. Get up, move around, and I'll put everybody online in a group breakout room, and I'll give you 5 minutes. So most of us were spanked as a child. Did it do any good? Does anybody have any feedback? Do you think it helped to be spanked, or was it counterproductive? Yeah, go ahead. Absolutely. I mean, what does it? I mean, anger is never good. If somebody's, spanking out of anger, that's probably a bad sign. And yeah, once children are old enough to understand, maybe communication should be that's goal there. Anybody else? Okay, go ahead. Okay, yeah, so the idea is to reserve it for something that's really, really, really important, like death, like running into a traffic or something like that. So something that actually poses that the punishment has to be for something that's so problematic that it's worth that the punishment, which would be an issue, right? How about you guys online? What do you talk about here? What did you guys come up with?
We talked about how spanking, like, it didn't really, for me personally, it worked. Like, it modified my behavior, but it ultimately just kind of left me a little scared. And I don't believe that, like, you should ever physically hurt your kid, because like that's like assault. Like, I don't think you should assault your kid. But I do believe that there are situations where like you can't necessarily give a timeout, but like slap on the wrist or like something of that manner would be appropriate. But I don't believe like you should be like getting a belt or like just causing fear in your child, because that's obviously going to modify their behavior. But fear and like anxiety, obviously, like we learned like when in learning, like it's not really good. So I don't think it's good. But I'm not a parent, so I don't know how to make that decision.
No, but absolutely good observation that you don't want to cause fear. Okay, the idea of punishment is to decrease the behavior. If you're causing fear of the punisher instead of decreasing the behavior, well, if you're causing any fear of the punisher, what you're doing is you're taking the focus off the behavior, the thing that kid has to learn, and really causing that anxiety. So good point. And anything else? What about should the U.S. outlaw physical punishment? Opinions, but anyone, if you're online, you can speak up. If not, just speak up here. Got someone online wanting to speak up? What do you guys think online? Did you guys talk about that?
I was thinking that I feel like it should be banned to be able to hit your child in the face, other areas other than their butt or their wrists, if that makes sense. And they shouldn't be able to use certain things like belts or spoons and stuff like that. But just regular spanking is okay if that works for you.
Right, okay, so a vote that it's, that there should be some kind of limit, like when it's assault, like Mark said, I mean, you shouldn't be hurting your child. I love it, she mentioned spoons. My mother had a spoon. She's like, oh, it's just a spoon, it can't. Spoons can be a dangerous thing. I think it's for the kitchen. I've heard so many people say my mom had a spoon. Anyway, what about you guys? Do you think it should be outlawed? Not outlawed altogether? Yeah, so maybe just it shouldn't be assault, it shouldn't be causing, I mean, clearly abusive behavior is wrong, no matter what kind, right? Mind you that, we tend to focus a lot on physical punishment, but there is such a thing as emotional abuse. Right? Sometimes it's a lot easier just to have a spanking than to have your parent subjecting you to, the silent treatment or refusing to validate your feelings, or, there's a lot of abuse that can happen that doesn't leave any physical marks, and in fact, it doesn't require touching the child at all. So while I think it's very important to protect children from physical abuse, sometimes we also need to think about that emotional abuse as well. What about timeouts, or did anyone think of a good alternative to spanking? Yeah, I mean, that's what I did with my kids. I'd make them run around the house and do push-ups, but I also keep doing the same thing. That was basically my punishment, take something away, and then I'd forget where I hid it, and then be. Yeah, okay, so this is always an interesting issue. It's hard because people will observe, well, should the government be outlawing it? There's a lot of different things. I mean, some people, like my last class, I had a class, my earlier class is a classroom full of people who are actually kind of pro spanking, and thought that if we outlawed it, we'd have generations of really horrible people being brought up. So, everyone's got their personal story. Okay, let's move on to, we talked about, we defined developmental psychology, we talked about developmental research design, we really touched briefly on the genetics. Genetics is certainly a fascinating topic. And, there's basically any kind of trait is coming from a lot of different places. It's not like there's one gene that makes you aggressive or smart or whatever, or one, mostly it's happening all over the place. So it's quite complex. If you're interested in it, you can study behavior genetics, really, really fascinating stuff. I unfortunately do not know as much as I should about it. So let's go on to prenatal development. So developmental psychology really begins at conception. Conception that's when the female becomes pregnant, okay? That's that moment when the sperm and egg unite and they form a zygote. And I'm going to give you the definition of that in a minute. The zygote then travels down the fallopian tube to the uterus, where it attaches to the inner wall of the uterus. And then it starts to reproduce itself by mitosis, breaks apart, okay? And in that zygote, there's already your genetic blueprint. Everything that is going to be developing is already present in that moment when you fertilize the egg. How that development unfolds can be affected by a lot of things in the environment, and we'll talk about that in a minute. But you already have your blueprint at that moment. So here's some terminology for you. Fertilization is that moment. okay, of sperm and egg getting together. The zygote is that cell, okay? Now, we've already seen these definitions, monozygotic twins are identical twins. Dizygotic fraternal twins, okay, for monozygotic, they share everything because one zygote splits into two separate masses, each of which is a separate embryo. Fraternal twins, we have two eggs fertilized by two different sperms. So dizygotic twins share about the same, an average of 50% genetic material, just like brother and sister. Okay, they are not more alike than any other two siblings of the same mother and father, right? Monozygotic, they're 100% of their genetic material, which is why it's so interesting when we look at these twins raised apart and find they share so many interesting characteristics. That shows that genetics has a lot to do with who you become. The germinal period is that first 2 weeks after fertilization, when the zygote moves to the uterus and implants in the lining. Okay, from 2 to 8 weeks after fertilization, we have an embryo. So we have a zygote, and then at about 2 weeks, it's an embryo once it's implanted. The embryonic period is from 2 to 8 weeks. That's when all the major organs and important structures are developing, okay, and the organ itself. This is a critical period. A critical period is a time during development, and it can be within the womb, it can be later, when environmental influences can have a really huge impact on the development of that organ, right? We talked a little bit about it on Monday when we talked about how language might have a critical period. A sensitive period is when it's sensitive, critical, it's like there's a huge change. It could be the development or not of language, for example. Keratogen, which I hope I'm pronouncing right, I always look that up, any factors that can cause a birth defect. During the embryonic period, is a critical period precisely because certain chemicals and so forth can cause a birth defect. So that's really changing the viability of the organism. And we're going to look at that. So, for example, here's some teratogenetic so mumps, measles, and rubella, German measles, rubella. If the mother gets these things when she's got an embryo inside her, it can cause the embryo, the baby once it's born, to be blind, deaf, have heart attacks, brain damage. It's a big deal. This is why, if you have not already gotten your MMR vaccine, if you want to get pregnant, if you're a female, you should get it. Most of us already have it, but I know there are some people who have false beliefs about this. No, the MMR vaccine does not cause autism. So it does. Marijuana, so too much pot can cause a child having a irritable nervous, uncomfortable infection. So much of it, cocaine causes heart, overt respiratory problems. So a lot of drugs can actually, this is just a small example. There are other drugs. Alcohol, we talked about this on Monday when we talked about intellectual disabilities. I briefly mentioned fetal alcohol syndrome. If the mother drinks too much during the child can have fetal alcohol syndrome, intellectual disability, facial malformation. Children with fetal alcohol syndrome, they have broad foreheads and their eyes are farther apart. I was actually, a long time ago when I was in college, I went with some friends to my friend Grace's house. We stayed there to watch the picnic, which is a horse race here in Baltimore. And at breakfast today, morning the picnic, his mom looked across the table and said, "Did you have fetal alcohol syndrome?" Totally did not, but it was funny. Everybody was horrified. But yeah, it's a pretty bad thing. And we're telling you now that if you are planning to get pregnant, don't drink or drink very little, right? Right now, I think it's pretty much a zero tolerance thing. So, I, with my first child, I got pregnant like right before I went to a wedding and she drank a lot, so she made me like, okay. However, one session of drinking when you don't know you're pregnant, obviously is not going to cause fetal alcohol syndrome, but it's better to avoid it if possible. Nicotine, bad, don't smoke. Bad to do it when you're parent. It can actually cause miscarriage. Mercury is a bigger bad. Mercury in thermometers, right? So that, those pregnant. Mercury is a poison. They don't even allow it in Finland anymore. So yes, another thing you don't want to be exposed to high doses of vitamin A can cause a heart attack. Not good. Even caffeine can be problematic. You should cut back on your caffeine intake when you're pregnant. My second child, one of the ways I knew I was pregnant, one day I got up and took a coffee. This was when I had that coffee every morning when I started to feel more. So what my body telling you, but usually your body doesn't tell you. You just have to be smart and avoid it. Also, because brain storms, really bad. Toxoplasmosis can be present in cat litter. So don't feed the cat litter if you're pregnant. Even hot water. Getting too hot with your core body temperature when you're in the critical period of development. Even if you go for a run, so if you go for a run and you get your heart gets up too high and you're in a place where you can't cool properly and you can time it, your core temperature can be too hot for the fetus or embryo. So no hot tubs, etc. And there's many, many more. These are just a small example. Okay, so after the embryonic period, we have the fetal period. That starts at 8 weeks and continues until the baby is born. So the fetus, in this time, I'm sure you guys know this, okay, but just in case. 8 weeks till birth, the fetus is in the amniotic sac. And that's where a whole bunch of exchange of liquids happens. That's how they get nourished. The placenta is all the inside of the uterus, right? That's what develops there. It allows exchange of nutrients. From the developing child. Viability refers to the point at which an infant can survive outside the mother. You guys have probably heard this in terms of the abortion debate. Nowadays, by 22 weeks, most infants have a very, very good chance of surviving and becoming perfectly healthy. Used to be there wasn't as good, but now with technology, 22 weeks, you're probably going to have a survival rate. It can be two terms, severely premature, but probably viable. So miscarriages happen. So miscarriages is just when you have a spontaneous abortion. Okay? Not all embryos become embryos, not all embryos become fetuses. Okay, nearly a third of implanted zygotes are rejected from the uterus. Okay, they go to be implanted in the wall of the uterus, and the mother's body rejects them. There's usually a reason for this. Most of them are defective. And sometimes it's hard if you're actually trying to get pregnant, but most of the time there's a very good reason why the uterus is not accepted. And this is without being exposed to anything bad. This just happens because, well, maybe you were exposed and that's why that's defective, but it can just happen for different reasons, right? So things that can contribute to problems: inadequate maternal diet, okay? If you don't eat properly, you can have premature or low birth weight. Low birth weight babies have increased risk of dying. For example, sudden infant death syndrome or other issues. Inadequate maternal diet isn't just about the weight, it's about how healthy it is. Actually, people who are very overweight can also have a tendency to have low birth weight babies. The thing is to eat healthy, just like everything else in life. We should eat healthy. So how do we know if a fetus has pregnant? Probably the first procedure you have when you're pregnant is ultrasound, also called a sonogram. Okay, that's They could just use an imaging procedure, which allows them to look at the developing fetus. If it's early enough, they can actually like estimate, even if you have no idea when you got pregnant, they can make your bone and estimate within a few days when that baby could be due. Okay? Once it's no longer, that's not possible. Now it's not on this slide, but then there's also a blood test that they do before animation teaches, which is 16 weeks. And they do a blood test to tell you whether or not there is a increased probability of certain birth defects or abnormalities like Down syndrome. Okay, so normally you might take this blood test, and then it might say, okay, so there's a increased probability of Down syndrome, for example, so maybe you should do something. I think it's about 16 weeks. It's when you have to have enough. The amniocentesis is a big gigantic needle into the uterus and take a little bit of amniotic fluid into the amniotic sac. Big needle, and then they analyze the fetal cells that are floating in there. Okay. They can't be done until the procedure is safe enough. So it has to be when there's already enough amniotic fluid that you're not risking the fetus. And so that's why it's a little later. Usually, because the probability of birth defects increases with the age of the mother, especially if there's also an older father. I think they advise the after the age of 35 to pursue getting amniocentesis. This allows them to detect a lot of most abnormalities. And some people, it's a decision, right? Some people will say, well, I'm going to have a baby anyway, so why have a big gigantic thing stuck in my stomach? Other people opt to do it. There are some disorders that make this cancer not viable, so even if they're born alive, they can die within days. So some people like to know that, even if they're not going to do anything, they want to know just so they can prepare emotionally, right? Decision you have. Okay, birth. Not going down. So unless the baby is premature, birth occurs approximately 30 to 60 days after fertilization or 60 days after the actual period. So it's 40 weeks. Pregnancy is 40 weeks, but they start counting after your last menstrual period. So before you're actually pregnant. It's about 38 weeks from the time from conception. Babies are born with a lot of reflexes. Okay, they're pretty helpless. Human babies are not like cows and whatever, go around surviving. Human babies have to be cared for, but amazingly enough, they are born with these instincts. The first is the grasping reflex. If you put the finger in a baby's hand, they'll grab it, and they train it so much that if you lift them up, they can actually swing by their hand. Even though their babies have no strength, that grasping reflex is really good. The startle reflex, the moral reflex, that's like, when they get startled, they go like this and start screaming. So they do this kind of interesting thing. Moving reflex, when you touch a baby's cheek, it moves towards the touch and opens its mouth. It's looking for a teeth for nurse, okay? Second, you can see the second reflex up there. If you move a baby along something where it can feel the ground or the step, you can go obviously months and months away from walking, right? And then finally, the second that they're born knowing how to go. Normal babies, right? Some might have issues with it. This is, and we're not even going to try to show the trailer because we know we don't have sound, right? I got to solve that. This is a really cute movie on Netflix. It follows this baby is someplace in Africa, I don't remember where. There's another one in Mongolia, another one in Japan, and another one in San Francisco, I believe. It's been a long time since I saw it. It was really cute if you want to really watch babies develop in different cultures. They share a lot of similarities. Okay, physical development. Any questions so far? Overview of baby development. Huge changes, tremendous motor development from birth to age 2. The baby is born, it's not, whether those reflexes you just saw, it really can't do anything, right? It can't even roll over. And we'll look at the timeline on these three motor milestones in a minute. The brain also is going crazy developing, right? It consists when they're born of 100 billion neurons. And I mentioned before how some pathways are developed and some are lost. Some are synaptic pruning is the word for how unused synaptic connections under the synapse where the neurons communicate are cleared away, and it allows for other pathways to be strengthened. So what is used is strengthened, and what is not is stripped. Okay, does that make sense? So babies are born with really bad eyesight, and they can smell and taste if that develops a little more. So they can hear very well. Okay? They can recognize their mother's voice really quickly, probably because they've been listening to it in the womb, right? But they can very quickly identify people by voice. Really important to talk to them. They can't see with a dot. 2300 to 2800, the beginning is all blurry, and it improves progressively. So you'll notice that toys for babies tend to be a lot of black and white patterns. That's because that's about all they can see. And that they really don't distinguish in finer patterns. They don't distinguish the differences. They don't differentiate between colors. So, at the beginning, it takes really obvious patterns. They're also really drawn to faces. And I think maybe we'll talk about that later. Babies really are attracted, drawn to look at these faces. Taste and smell, they're pretty good. And by the time they're 4 months old or so, they're fully functioning. An interesting thing, how a lot of children don't want to eat a lot of things. Part of this is because they can taste so much better than you can. By pretty soon in life, by the time you're a teen, you've already shown your taste receptors by putting on a lot of salt and a lot of spice to get the immune. Okay, when they're young, they taste everything. So often the rejection of something is just because it's a new taste that they're detecting a tiny difference in. And you should have to keep presenting it. Baby food doesn't have salt. Okay, or doesn't taste salty. They might have salt in it. They don't need that. They taste so much at the beginning. Oh, out of order. Motor skills develop really quickly. So here's some of the motor milestones I was talking about. Around 2 to 4 months, if you put babies on their stomach, they learn how to raise their head. Now you'll first put babies down to sleep on their stomach because of risk of sudden infection control, but they do need part of their stomach so they can learn how to push up, so they can learn how to roll over. And these are the physical milestones that have to do. About 2 to 5 months, they can roll over. So that second period is the process of figuring that out, right? And about 4 to 6 months, they can sit out with support. They just kind of prop them up, or sometimes earlier, picking up without support 6 to 7 months. Most babies are giving that by 6 months, but the window of normal is really big. And as they get older, it's bigger. Probably 7 to 8 months. Most of them, not all of them. My oldest son first learned how to drag himself like a soldier on the stomach. He didn't actually start crawling until he was about 9 months old, I think. So because walking 8 months, 10 to 18 months, even later. Talking, I mean, we saw that actually on Monday. We saw how they start cooing around 2 months, and they start babbling, and they progress to 1 word, and then telegraphic language, and finally full sentences, usually by the time they're 3. Remember, the talking thing is also about motor control. If you can't control fine motor skills, you cannot control your tongue, right? Your tongue is a vital part of talking. So maturation refers to the regular unfolding of your organism and its abilities, okay? So maturation includes a lot of stuff like learning to crawl, learning to walk, and so forth. Cognitive development is the development of the cognitive stuff, cognition, thinking, problem solving, and memory. That's what we talked about in the last chapter. All that cognitive development is really important. Mental concepts, going through experiences, playing we get into a lot of really interesting developmental theories. So let's start with cognitive development. There's two important concepts about cognitive development. One is assimilation, and that's when we incorporate new information into our current way of thinking. Okay? We assimilate it. We put it in the way we're already thinking. Compare this with accommodation, which means changing the way we think, or your schema. Now, we talked about schemas before. So new information that does not fit can be included. So some things are so new, we can't fit them into the current way we think about it. Current schema. And we talked about schemas, the whole way, our framework for understanding scripts, we talked about schema for a series of events, going to school and so forth. Remember we talked about that last Monday, maybe, or maybe last week, I don't know. So how does cognitive development work in childhood? Now, the first person who really talked about this assimilation versus accommodation, well, that we learned is Piaget. John Piaget. He observed a lot of children. His own offspring, grandchildren, a lot of other children. And based on his observation, he proposed this stages of cognitive development. And he talks about how children got this new knowledge that allowed them to develop. He talks about that assimilation, the accommodation. And let's have a look at that and try to get done with Piaget at least today. So Piaget's first stage is called the sensory motor stage, first age 2. So senses and motor, they're having this great motor development, their vision is developing, etc. And the idea here is that infant actually relies on these developing senses and motor abilities to interact with objects in their environment. They learn to coordinate their crawling and their touching, they learn to reach out to touch something, to get knowledge of it. They start tasting things. Okay, they start using their senses and their motor development in order to interact with their environment and learn about it. So one of the first things that infants have to gain is object permanence. This is knowing that something exists when it's not in sight. The way they catch them, the babies do, they have a ball or something, or a blanket. Before the infant if something is hiding, it still exists. And they think, they thought as because of mental representation, symbolic thought begins. So for a little baby, what is present and what isn't doesn't exist. Right? So if they cannot see something that doesn't exist, that might be the origin of my urge to close my eyes and close them, they don't exist, right? Or maybe they really don't. And that's because they don't have that symbolic thought that allows them to represent things they can't see in front of them in their head. That makes sense? So this is Piaget explaining why with a small baby, if you have a wanted toy, but you cover it up and they don't ask for it anymore, they don't reach for it, because they don't know it's there. Because they don't have that cognitive architecture that allows them to have that. Remember we talked about concepts and images in the last chapter? Babies still don't have that, they have to develop that. So next we get to the pre-operational stage. This is ages 2 to 7. Basically preschool, and they're starting to get language. So before age 2, babies, remember they prove, they babble, they use one word, right? They point to use a word, and then they use a telegraphic which is, toy, mom's toy or whatever, something just that hurts the things that actually need to be. Around age 3, they start actually forming sentences and they can actually communicate in more efficient, and that language, as they learn it, they can explore the world more. So there's some things that happen that occur in stages that happen with the right? Wow. So typical of small children is the inability to see the world through anyone else's eyes. They are little egocentricism. Now we know now that PSA was not entirely correct. We've done a lot of experiments with babies that show they actually can be empathetic. They actually do worry about the perspective of other people. But for PSA, they will basically say totally egocentric, right? Integration refers to the tendency of a young child to focus on one thing, okay, one thing in their environment and totally ignoring everything else. Okay. For example, if you give a small child, a baby, stuffed animal, sometimes they'll like glom onto its nose or its ears, and that's it. That's the whole thing and the total of the thing for it, right? Conservation. Okay, this is an important milestone when actually children understand it. Conservation refers to understanding that if you change the appearance of something, it doesn't change it. Okay, it doesn't change its nature. We're going to see an example of that, but that's like, and I think the example I'll show you is when you have liquid in a short fat glass and you pour it into a tall thin glass. Now, before the age of the understanding of conservation, they're going to think there's more liquid in the tall thin glass just because it's higher up. Right? Whereas, you know, if you're like me, you might have tested some of your glasses to see if they have the same amount, so you don't give somebody more of a drink than another person, right? Right, that's like a little advanced of it, but irreversibility. So PSA notice that young children cannot necessarily mentally reverse an action. Okay, they just keep going forward. Oh, here's a conservation experiment. Okay, so you're testing 2 glasses, equal glasses, and you pour one into a taller, narrow glass. Okay, if the child is pre-operational, so somewhere between 2 and 7, they're going to start understanding this. But before they understand it, they're going to think that the taller glass has more, even if they watch you do it. Okay. And number, if you put name, look at number, it says increase the space between them. The child is still going to see that it's comparing the length, or you could do it like circle, just widen the circle. If you ask which one has more pictures, they're going to think the one that looks bigger because it occupies more area. Okay, they're just not understanding that conservation yet. Does that make sense? Okay, so important milestone is understanding that. I have noticed that some adults don't understand the glass thing either. So the third stage for PSA is concrete operation. Right? This is your school age kid and can understand a lot of logical thought processes, but theoretically is not capable of abstract thinking. Concrete because concrete concepts, right? Understand bold, but not pi or something like that, as in mathematical. Okay. Finally, you have formal operations. This is the fourth and final stage of cognitive development. Usually happens in adolescence. Okay, so your concrete operational is usually up to age 11, 12. And then after that, you come to the formal operations. If you do, not everybody does it. And this is just relativistic thinking, abstract concepts, just a greater extent of abstract thinking. Okay, so here's our summary. This is the table from the textbook. And the big change from sensory motor to operational is mental representation. So concepts and images. We talked about in the last chapter. But they still can't do a lot of logical reasoning, or they don't have conservation yet that we talked about. happens is constantly operational, and then it starts to understand the conservation, even if they're safety, they start categorizing things and so forth. And then finally, you have formal operations, and we have abstract thought. Okay. Any questions? So we also have another cognitive developmental theorist was Vygotsky. He really, rather so for Piaget, it was all about these each child and the way that they develop within themselves and related to the environment, which allows them to learn, right? Vygotsky really stressed the importance of the social context and social interaction. Okay, and social interaction facilitates learning. It helps. So the idea is that adults and older children help children learn, prepare them and help them learn concepts that they can't yet do. And this is called scaffolding, I think it's here. Okay, so the two important concepts. First is the zone of proximal development. And that's just the difference between what a kid can do alone and what it can do with help. There's going to be stuff that they can't do at all. That's outside the zone. Stuff they can already do, okay, doesn't. So it's just the difference. Here we have a nice definition, difference between actual ability and the potential development that they can be guided to learn what to do. Vygotsky talks about private speech after he comes to himself. Vygotsky actually thought that helped. So, you know, when a child will sit and talk itself through doing something, Vygotsky thought that was actually helping them advance to actually progress through stages of cognitive development. I still do that. Anybody else still talk to themselves? I guess we are still developing, right? Okay. Scaffolding is exactly what I was mentioning before. That's when someone, an adult or an older child, helps them, helps the child who's a less skilled learner learn by literally scaffolding. You know, scaffolding is the thing you build up so you get outside of the house and paint it. Well, they're providing that assistance or help so that a child or a younger person or a less skilled person can learn more easily. That's what I'm doing. I'm scaffolding you guys a little bit. So Piaget totally ignored the social aspect of learning. Vygotsky really centered in on it. And we've talked about it before. He thought that language absolutely shapes thought. Okay. I think, wait, let's look. Okay, I guess we can do 2 more slides. Gender role development, gender. Okay, sex is just your biological sex assigned at birth. So you're either male or female. Gender is like women or men. Features that in society associates with being a man or a woman. Gender identity is your internal sense of whether you're a man or a woman or whatever else. We're going to talk about this in chapter 10. I think there's a little more in your textbook, but we're going to talk about it later. One issue of cognitive development is a lot of different ones, but autism, we mentioned autism, I think, briefly the other day, so what's this class and another. Autism spectrum disorder, developmental disorder, encompassing a range of problems in thinking, feeling, language, and social skills. Okay, people on the autism spectrum have trouble understanding other people. They have trouble with serious minds, understanding the intentions and feelings of other people. No vaccines do not cause autism spectrum disorders. And as I mentioned, I guess on Monday, severe, lower functioning autistic people have very low intelligence. And they have a lot of issues where they're everywhere to high functioning. They're very intelligent and do a lot of things, but have a lot of trouble with social skills, understanding the emotions of their own emotions and others. And we talked about that emotional intelligence last time. Okay, so we are done with time, so we're going to stop right here. Are there any questions? No? Okay, so more on Monday, and it looks like in this class we got 2 more, so we will have more time. Perfect.